Awesome. Thank you for coming. My name is Jake Brukhman. I'm the founder of Coinfund. I'm going to be speaking to you guys today about generalized mining and the third-party economy. This is sort of a little update of a talk that we did at DevCon 4 in Prague this past year. And tell you a little bit about Coinfund. We're a blockchain investment firm. Our first fund came out in July of 2015. And we've been in the space before that, so we have a kind of long history in the space looking at blockchain technologies and investing in digital assets as well as companies working on blockchain tech. We have a multidisciplinary team of 9 today based in Brooklyn, New York. We have Dimitri, also NSF, working part-time with us. And we study consensus, crypto economics, and financial structures around blockchain. In 2018, we launched our second fund backed by the partners at Venrock and David Pakman. And we consider ourselves kind of full-stack investors in the sense that probably before many other investors, we decided to invest in not just the base layers or protocols of blockchain, but also the middleware and also dApps. And in addition to that, we invest in kind of traditional company rails that get money into crypto and help issue assets and help to be compliant. And finally, and most importantly, we like to dog food. We like to participate in the decentralized networks where we invest and just in general. And that's how we come to Generalized Mining. A couple of days ago, you may have got some press coverage on the launch of Grass-Fed Network, which is essentially a quant wing for Coinfund. But unlike traditional quant, which tends to write quantitative strategies on trading stocks, right, or even digital assets, we think of this more as a vehicle that plays crypto economic games with networks for a return. And so what I'd like to do in this talk is tell you kind of how we conceive of generalized mining, what that means and what it is. And because this is a developer-focused kind of conference, we'll just walk you through one of these games that we spent a lot of time on at Coinfund, and it was a great experience. So generalized mining, what does this mean? All theses kind of begin with some assumptions, and the assumption behind generalized mining is that decentralized networks will proliferate. There will be many of them, and also that decentralized networks are kind of public goods. They're publicly owned. They're owned by the users and inventors of those networks. And when we think about what decentralized networks were in 2015 and how they might have colored our view of what decentralized networks are, well, in 2015, you basically had cryptocurrencies, blockchains that implemented pure currencies like Bitcoin, had a couple of asset issuance platforms like NXT, Counterparty, and then Ethereum came along and really lowered the cost of creating decentralized protocols with a smart contract platform. So in 2018, or really 2019, if you look at the market and kind of try to point out what decentralized networks are out there in production, we really see quite a bit more than that. We see networks that offer storage space or computational power. We see networks that are trying to implement social media like Steemit, and in those networks, content curation is kind of the important metric and how well that works. More recently, we've had decentralized finance come onto the scene and basically create protocols for traditional financial services. And those protocols also have a lot of places where third parties need to participate in those protocols for them to work. And finally, things like TCRs or registries or ENS or Handshake, which is kind of trying to disrupt DNS, is also a use case where you need many third parties to participate for those kinds of networks to work. So in short, decentralized networks, if you believe that we'll see many such networks in many different verticals, they need services to be provided not by a central company, as is usually done in kind of traditional technology, but by actual network participants. Let's just kind of maybe go through how this developed over time. In the first such network, a proof of work cryptocurrency blockchain, you generally had two kinds of participants. Miners, these are the people who use hardware to validate transactions to make the network work, and users who are sending money to each other. And then the miners would get compensated in the network asset, like Bitcoin. Then we started to think about proof-of-stake systems, and in proof-of-stake systems, miners became validators. And then we also got this additional concept of, if we're using a delegated proof-of-stake system, we might delegate some of our stake to another party who will vote for those validators on our behalf. But then this keeps going. When you get into a decentralized social media network, you now have four kinds of participants. You have witnesses, which are the validators of Steam. You have the people who are actually creating content and publishing on the Steam platform. You have people who are curating content, meaning they're upvoting and downvoting certain content, and the theory is that the good content should go to the top. And the people who have predicted that some piece of content is good, by the measure that it went viral or something, they get rewarded. And interestingly, this is where we start to see content curators being bots as well. The Steam ecosystem has a number of bots operating on it today. We heard about scalability on the last panel, and in layer 2, and this is a really compelling kind of case for third-party participation, is you need things like hubs, watchers, routers, dispute resolvers, and other kinds of liquidity providers for layer 2 or state channel networks to actually function. Has anyone heard of LivePeer? LivePeer? Cool. For anyone who doesn't know, LivePeer is a company based out of New York. They're creating a decentralized network for video streaming and encoding. And out of the gate, this network has 6 kinds of participants. You had sort of the early investors who brought the team to fruition. You eventually have users or customers. This is a delegated proof-of-stake system to pick which transcoders are going to be doing good work. So this has a notion of delegation and delegators in the system. You have the transcoders who are actually transcoding the video and getting paid for that, and who are curated by the network. You have Merkel Miners, which I'll talk at length about. And basically, these are third parties who help to distribute the LivePeer token supply. And more recently, in their proposal that they released a couple of months ago, they're even going to have a 6th kind of participant called orchestrator. This is for scalability. So an orchestrator will coordinate many different transcoders to enable linear scalability. And we can go on, right? We can talk about lending protocols and liquidity provision. We could talk about resolving prediction markets as it's done on Augur. We can talk about CDP liquidation and Maker. And what we realize is that there's actually a huge number of roles that are either in production today or are poised to be in production as these protocols hit the market. So in short, decentralized networks, they need hardware to run on. They need software to facilitate all of these functions. They need public stakeholders to govern the network, and a long list of domain-specific supply-side services to enable the functionality that that particular network or vertical represents. And so generalized mining is this idea. It's also been variously called Mining 2.0 or supply-side services, network service provision, or even from the investor perspective, it's been called active network participation, is the idea that you have a supply-side service that you're providing to a decentralized network, and that decentralized network compensates you for that service on protocol in the asset of that network. And the market of all of these opportunities is almost like its own economy, sort of if you extrapolate it out in a world where many of these networks exist. They're acting as public goods, and they're actually providing services in place of Amazon AWS or something like that. Just a couple of more things to say, like how do you make sense of all of these opportunities? The way that I break it up in my mind is that, on one side of the spectrum, on the red side, you have opportunities that are really hardware intensive. So this would be like proof of work mining, right? You have a giant $100 million data center, and here you're competing on how much hardware can you run, and how efficiently can you run it. On the other side of the spectrum, this is where I think, as we'll see, kind of funds will have a better time participating, is this idea of software or proprietary software strategies that you can run. And these are things like, again, crypto economic arbitrage, helping make stable coins stable, or again, liquidating maker CDPs. These are opportunities that don't require a lot of proprietary hardware or hardware scale. You can run these on regular computers, but the competitive advantage of someone who runs this strategy is the fact that they're smart, that they can come up with a proprietary strategy of how to perform these services better than others. And somewhere in the middle, it's a mix of hardware and software, is probably this idea of staking, which we're most familiar with. We have a market of maybe 100 companies going out and doing staking provision today. In staking, essentially you take some of your asset, you put it toward a network, and you earn a rate of return in a token-denominated way. I think classical miners, or people who already have data centers, they're well positioned to go into the generalized mining opportunities that have hardware provision, that have a lot of computational intensity. I think quants and crypto funds have an advantage in the software-intensive side of this market. And of course, we see staking companies and their customers kind of going into the middle of this market. And one interesting thing to consider is that there's a lot of opportunities here, and they're all very, very different. And staking, by far, is not the main opportunity. It might be the main opportunity today, but it's not going to be the main opportunity tomorrow. And even within staking, not all staking crypto economics have this idea of delegation. And so if they don't have that idea, they're not a great candidate for staking companies. And so there's an opportunity for other players to take advantage of them. In the second part, I'd like to take you through an actual crypto economic game that was actually put into production by the LivePeer team. How many people have heard of the LivePeer Merkle mine? Okay, so relatively few. If you Google LivePeer Merkle mine, it gives you a little text back on what that means, but I'll go through that here. And essentially, a LivePeer Merkle mine is a crypto economic game instrumented by the LivePeer team that implements a decentralized airdrop. In other words, the distribution of tokens to some set of Ethereum addresses. In particular, the way that LivePeer did it is they said, let's take a snapshot of eligible addresses. It turns out there were 2.6 million Ethereum addresses that were eligible. Eligibility just meant you had maybe 0.1 Ether in there or more. And if you were the owner of one of these eligible addresses, then you could claim about 2.44 LPT. It didn't matter if you had a lot of Ether or little Ether in the address. Your reward was always the same. But obviously, this is quite hard. Many people don't know how to use smart contracts or just simply weren't aware of it. And so LivePeer created a crypto economic game where third parties can go and redeem that LPT on your behalf. And essentially, when a miner would mine your address, that 2.44 or so LPT would be dropped into your address. 63% of the token supply of LivePeer was airdropped in this fashion. And the way that the game set up its incentives, it said, okay, we're going to do this for 15 months. When this begins, basically miners can go and claim LPT on behalf of other addresses. And when they do, most of it goes to the address, but a little fee goes to the miner to economically incentivize them to participate. Over the course of the 15 months, the fee goes from 0 to 100%. So somewhere in the middle, we expect that, 50% of that 2.44 goes to the address, 50% goes to the miner. In the beginning, all of it goes to the address, and none goes to the miner. And at the end, all of it goes to the miner. So that's what I mean by every block, the miner fee goes up. In order to claim the LPT, a proof of work has to be done. And this is what a Merkle proof is. It's essentially a computation, which takes as an input that particular address, does a little bit of proof of work. It takes about 30 seconds to do this proof of work on like a regular computer. And then the miner can submit this proof of work to the smart contract, resulting in the vending of the LPT and the airdrop. So why would people want to do this? Well, the core intention of an airdrop is to create a wider token distribution, right? It's the idea that if you can give many stakeholders some of your asset, this is ultimately going to be better for building and bootstrapping the network effect of your network and system. The other pros is that it's hard work. You know, doing an airdrop, if anyone has done that, is not easy. So from the team's perspective, it's actually great to incentivize third parties, you know, kind of to spend their own money and to make a speculative bet on your asset and do the airdrop themselves. And finally, this is, I think, a very democratic activity because it's radically open. It's open to literally any third-party participant that takes the time to understand the system and to implement kind of a mining software or just use some commodified mining software to do it. The cons of Merkle mining is that in general it's more costly than a centralized airdrop. If the team were to spend their own money on the airdrop, they might be able to get away with a smaller check that they would have to pay. Merkle proofs in themselves, just like most proof of work, are not ipso facto like useful. They're just there to create security. And finally, in the Merkle mine implementations that were launched to date, they have been susceptible to front running, meaning someone could come in and if they see you submitting a transaction with a proof, they could sort of snatch that proof, resubmit it with a higher gas price, maybe get in. And this has actually happened during the mine, though didn't have a huge impact on the outcome. So these rules set up a pretty interesting crypto economic game. Put yourself in the shoes of a miner, and you have a bunch of trade-offs. So for one, if you mine too fast, you won't get a lot of fees, because remember, the fees are very small in the beginning. You have to sort of wait along that 15-month timeline in order to get a bigger chunk of the reward. But if you mine too slowly, your competitors will come in, perhaps, and take the fees for themselves and leave you with nothing. So you have to make a decision of what is the optimal speed with which I mine. If you pay too much gas, in other words, you're very eager, then you will end up overpaying for LPT. This is actually a way of converting Ether to LPT tokens, because that's in effect what you're doing. But if you pay too little gas, then your transactions won't be confirmed in time. So the question becomes, what is the optimal gas for me to pay, and how do I calculate that? Finally, you know, the Merkle proofs are pretty expensive to compute. In fact, if you were to do it one at a time at 30 seconds a pop, you would end up with about 902 days of computation. So you have to decide, do I compute these proofs one at a time as I'm mining? And if you do that, then you have placed limits on how fast you yourself can mine. Or do I mine them all up front? And if I mine them all up front, maybe I can sort of preempt other miners by redeeming all of the proofs if I notice that my competition is sort of ramping up. And of course, you can create a parallel computation which mines this whole thing, but it's not necessarily cheap to do that. So here are some of the results. This was written up in Multicoin's post about new models for token distribution, which talks about Merkle mining. Instead of 15 months, this mine ended up taking 68 days, which is actually kind of bullish. It means a lot of people were willing to take the risk of holding this kind of asset and also spending Ether on redeeming it. Merkle miners spent about 2,000 Ether, about $500,000 worth of Ether at that time in order to execute this mine. And there were a lot of them. We were actually the single biggest miner, which you see reflected there. And the LPT mined in that column is just the rewards that went to the miner. It doesn't count the actual LPT that got airdropped to the folks who were eligible. And if you're interested in diving deep into the economics of Merkle mining or thinking about instrumenting a Merkle mine for your own token supplier network, check out this post on the case study. It's a lot of learnings here in this process that were good and bad. And certainly we would love to see more teams taking on this model and trying it out and innovating on it. So in conclusion, maybe decentralized networks will take over the world. We we think that generalized mining presents new opportunities for all the participants in these networks to, first of all, have a say in the governance of those networks. Second of all, to make a return for providing something useful to the network. And unlike, let's say, traditional quantitative trading that makes money for the sake of making money, when you do generalized mining, you're actually adding value and helping these networks to be sustainable and to exist in perpetuity. If you're thinking about doing stuff like this, come chat with us. We have some experience. And consider the role of these kinds of crypto economic games or third-party services within your decentralized network. Thank you. If there are any questions, I'd be happy to answer them.